Welcome to Mapping Tips from a Cartographer. My name's Sarah Battersby. I am actually a real live card-carrying cartographer. I have some degrees in mapping. I taught mapping. Now I research in mapping. I'm a member of the Tableau research team, and I'm the token non-computer scientist of the team. So I get to play primarily with the mapping teams. So we've got two different mapping teams. And so hopefully I have sufficient expertise to talk to you about some good cartographic practices. Just one tip on this. So this is listed as an intermediate level session, which does not mean that this is going to be like mind-blowingly complex. But it also means that I'm not really going to go into the nuts and bolts of, how do maps work in Tableau or that sort of thing. I'm going to focus a little bit more on what are good practices with maps? What are some of the gotchas that I run into frequently? What are the things that I think will be useful for you in terms of making better maps faster and having a good decision-making process as you go through working with your spatial data? So just some contact information in case you want to hunt me down at some point in time. My email address is up there. Feel free to email me. I have found after giving TC talks, I will get emails for like 8 months afterwards. All of a sudden it's like, I saw the recording. And it's awesome. I love answering the questions that you guys come up with, so don't be shy about sending an email. And if you want to find out about blog posts or other things that I write, I have a very low traffic Twitter feed. I am Maps Overlord, so if you're looking for me, it was a name that was gifted to me. It was not really my making up. So let's go ahead and get rolling. The things I'm going to do in this session, I'm going to start out with some resources. So I'm just going to front load all of that, and then we're going to totally dump the PowerPoint slides. And we're going to move into building up a couple Tableau workbooks. So if by chance you've come to this session in the last couple years, it will be different because I'm not going to show you a lot of slides. And we're going to build some maps. And I will admit, I am really, really terrified about building live workbooks in front of you all because I know that something's going to go really wrong. And we'll fix it. And it'll be like magic. Just keep telling yourself that. It's going to be like magic. So we're going to do some live map making. I'm going to go through 3 different map types. I'm going to talk about some good practice and decision making with each of those. Have some fun with them. How can you bling up your maps a little bit? We'll talk about everything from good tool tips to making classification schemes that really help you see different patterns inside your data sets. And talk a bit about context and whatever else comes up while we're building stuff. A few resources. So I do write blogs, and I put them on the community forums. So I answer a lot of forums questions, so maybe some of you guys have written in with mapping questions. I may have been the one who answered them because that is like my hobby when I have nothing that I really want to do on my to-do list at work. I scour the forums for good map questions. And when I get enough of a certain type of question, I end up writing a good how-to blog post that walks you through all sorts of intricacies of fun map stuff. So those all go up on my blog. I post those also on my Twitter account. I keep a pretty healthy set of workbooks on Tableau Public. And most of those are not designed to be National Geographic quality. This is like a super duper amazing Zen master designed map. Most of them are designed to have a lot of comments in them to explain what I did in the map and why I did it. So if you see something that's interesting, I'll explain what the technique is. That's the type of workbook that you can grab. And after TC, you'll be able to get these slides, and I have completed workbooks of what I'm going to be showing. And they all have pretty extensive comments on them, the completed versions of them. And they're actually already up on Tableau Public, should you want them. Just to lure you to some of those resources, I have things related to spatial binning. So if you want hex bins, square bins, binning into arbitrary geographies, if you have data points that overlap and you need to jitter them, if you want dual axis mapping, if you want heat maps. I wrote a Python script to make heat maps. Just seemed like something fun to do one afternoon. If you need to map polar data or use alternate map projections, it's all there for you. If anybody has map projection questions, please let me know. This is like my probably a little obsessive hobby. So some of the workbooks I've got all of the workbooks that I've used in previous years at TC. So from making spider maps to flow maps, working with dense data. And then I have the all-new 2017 workbooks, and you can see that they're a little bit denser with text. So they've got a lot of description about what's going on in each of those. Every once in a while, they also let me write blog posts for like the big Tableau blog. Most recently, I wrote one on 10 ways to add value to your dashboards with maps. And I think it has a lot of really nice examples when you want to look at how can you create a nice dashboard that is showing a lot more than just the spatial data, and what are some tips and tricks to making sure that your data is visualized well, thoughtfully, blends into the rest of your dashboard, and really helps facilitating finding spatial patterns. So those are some resources. I think they're, halfway decent. If you have problems with them, send me an email. I keep a sticky note list on the side of my desk of the next blog posts I need to write. I've got 3 of them already lined up, but I'm not afraid to put 4, 5, and 6 on after this talk. So just let me know. And we're going to make some maps. You ready for some maps? Yay! That's what I like, the good enthusiasm. Here we go. So we are going to start out with what a cartographer would call a choropleth map. It is probably not, we're totally going to start out with these maps as soon as they show up on the screen. Thank you. Yeah! So I knew that things would go wrong at some point in time. I just didn't realize it would be that, and it would be that soon. So we're going to start out with choropleth maps. So that's what their fancy cartography word for it. Just do me a favor, if you ever really want to irritate me or any other cartographer, call it a chloroplethe. Put the L in it because it's totally wrong. And like the cartographer ear is just like, oh my gosh, horrible. If you're using Tableau, feel free to just call it a filled symbol map, because I think that's what we call them. And every time I see it, I'm like, but they're choropleth maps. They're like, yeah, but no one uses that word. So choropleth maps, they're really just, you got a bunch of polygons, whether they're coming from our geocoding data sets or they're coming from a shape file or some other spatial file that you've brought into Tableau, and you want to show a single value in each one of those polygons. Filled symbols. So we're going to make one of these, and we're going to do a lot of fun stuff with it. So the data source that I'm going to be using, I grabbed a data set from the census. I like grabbing data from the census. It's really nice to use in demos because it requires some cleaning. So you'll see a little bit of the pre-mapping process. I mostly did it in advance because you don't have to suffer through all of it. But I wanted to show some of the techniques that we have for cleaning. So we're going to look at poverty status in the last 12 months, and this is the 5-year estimate from the American Community Survey. So again, our choropleth map, we're going to have one value per polygon region. The values are going to be the same across every area. And they're going to communicate sort of broad spatial patterns across the entire map. So I mentioned that the census data often needs a little bit of cleaning. So I'm going to give you a heads up on what I did, and then I'm going to show you how I did it. The main things that I had to deal with in this data set is the geography comes in as a county, comma, state. And Tableau can't geocode that outside the box. So what I need to do is I need to split that column into a separate county and a separate state. And that allows me to geocode it and use the built-in polygons that we have. And then I can start building my map. The second thing is all of the data comes in with these really, really horrible cryptic names. And instead of letting you know that we were going to be mapping HCO1 ESTVC01, I thought I would go ahead and rename some of that so you guys knew that we were mapping, say, the population living below poverty. This just a little trick I like to do when I'm making maps. So let's go ahead and start building up some maps and see what happens. So to show you what I did with the geography, so it came in as this county, comma, state combination. And we have an option to just split that. So if you right-click on any of the fields, you can transform and split. If you just choose split, we've got a whole set of identifiers that we look for. Comma is one of them. So it'll just automatically split it on the comma, and you get 2 separate fields called like split 1 and split 2. I renamed them to state and county and set them as geographic data types. So I've got now a state name and a county name. So I'm going to use those to geocode. I also renamed the cryptic fields. So I made a population below poverty level, and I have a population for whom the poverty status is determined. This is just a count of how many people in each county. Now, one of the things I did here that I find really useful with making maps is I put an underscore under those names that I renamed. And the reason I did that is because it always pulls them right up to the top of the list. So instead of having to like scroll through anytime I'm looking for a name, if I know I'm going to use something repeatedly, I just underscore it and throw it at the top. Or if I want to hide something and make sure that it just like exists but I never see it, I put a Z at the start and it just gets dumped at the end. So just some fun data organization tricks. So let's start out building our map. So we're going to build this at the county level. So I can just double click on county name. It's going to show up on my map. But I end up with 430 unknowns. Why do I get 430 unknowns? Because Tableau doesn't automatically know that the state for each one of these counties. And there are like 800 Lincoln counties and Washington counties. So if I add state onto the viz as well, it's going to go ahead and disambiguate those because now we have the two geographies to work with. The easier way to deal with these, if you make a lot of maps and you're using the same geographies, you can grab both the state and the counties and create a hierarchy out of them. So what the hierarchy is going to do is say, these two things live together. And when I use one of them, I want to be able to access the other one. And I know that states are bigger than counties, and states contain counties, so I want to be able to automatically disambiguate and jump between state and county geographies really quickly. So I just took the default for the hierarchy. I'm going to go ahead and add my counties back in, and I still have 430 unknowns. So the reason that happens is that I screw this up every time. Now I'm screwing this up intentionally because I wanted you to see me screw this up. But the thing is, the hierarchy is based on the order that you have them over here in your dimensions. So if I just drag state on top of county, and now I drop my counties in, it knows to automatically attach them to each of those states. Now the perk that I get with that is now I get this little minus sign next to state name. So if I don't want to look at county level, I just go back to states. Or I can expand it back to counties, or back to states, and back and forth. So it's really nice if you want to have that hierarchical relationship and jump between levels of detail in your visualization. So for what I'm going to do, I'm going to go ahead and just narrow it down to our lower 48 states. So I'm going to just keep those ones. And we're going to make our first map. So the first thing we're going to make is look at how many people live below the poverty level. So all I'm going to do is I'm going to drop that onto color, and I'm going to get a basic map. So when I see a map like this, first thing I think about doing is getting rid of all of the borders. Now, the reason I like to get rid of the borders on county-level maps on the United States or anything else where I have really small geographies is that the borders, I think, take away from the actual data. There are so many small, complicated borders that you end up with just a lot of lines and not so much of what is the continuous pattern across space. So we'll go ahead and get rid of those. And I'm going to pick a color scheme that I like a little bit better. Lately, I have been really enjoying the orange gold. So we'll go ahead and use that. So now we have our population and poverty. What is our pattern here? It's a population map. It's also used pretty one color. I'm not getting a whole lot of spatial pattern out of this. So when I see a map with the default stepped color scheme, and we always default to the continuous color scheme, we always default to giving you that continuous color ramp. If I feel like this is really just too homogeneous in terms of color, the first thing I do is I try it with stepped color, because that's going to insert some breaks in the color scheme. It's just going to give me 3, 4, 5 unique colors instead of potentially 3,000 unique colors that show me the exact values. So I'll go ahead and change that to stepped color. We'll make it 4 classes. And because, as somebody already called out, this is really just a population map, we're not seeing any particular pattern. This is something you always want to look for in your data sets. When I see one color maps like this, after I try stepped color, the next thing I do is I make a data distribution visualization of some sort. So I pre-made this just so you guys didn't have to watch me make both the chart and the map and put them together in a dashboard. But what this lets me do is look at the visual in the map and then the data distribution. So I can see that there are a whole lot of values clumped together down here on the lower end of the distribution, and we've got this one super high outlier all the way over on the right. And what that does is it makes it so I'm not using a whole lot of this color ramp, so I get that one color map. Since I've linked these together, it also means that we could start to dig out what some of these patterns are. So in case you didn't immediately look at this and say, oh, it's a population map, I could start saying, well, let me dig into these high values. LA County, let me get it to filter. Okay, maybe I won't get it to filter. I swear this worked earlier today where it like totally zoomed to the right location. Cook County happens to be where Chicago is. We got Harris County, Texas, happens to be where Houston is. Maricopa, Phoenix. We can really see that these are all the high population cities and the counties that belong in them. But we also see something else weird that's happening with this. I don't know if any of you guys caught on to the fact that the color that's in my little dot plot is not the same as what's showing up on the map right now. What's going on? So this is one of the biggest gotchas whenever you're using a map on a dashboard. Check to make sure that your color scheme is always going to be consistent. When I go to Los Angeles County, the legend just changed, so now I'm showing one value, population 2 million. When I go to Cook County, oh my gosh, it's exactly the same color, and my legend is now just 879,000. What's happening is that the default with stepped color is to, or the default with color is to give you a continuous color ramp that always adjusts to what you've filtered. So if I don't want it to adjust when it filters, what I need to do is go into color and edit the colors, and there's an advanced tab, and you can hard set the start and the end values. And what that's going to do is make it so that whenever you filter this data set, the color scheme is always going to be the same. This is particularly important if you want to put multiple maps next to each other on a dashboard and you want people to be able to make valid comparisons. Because if red doesn't mean the same in both maps, no one's going to interpret it right. Yeah?
What happens when you refresh your data? So now your data goes up to whatever value it is, 1.8 million, and your next refresh the data goes up to 3 million.
So the question is, what happens if you refresh your data when you have these values hard set? Honestly, I have no idea. But I will try it with a data set that I can refresh, and I can let you know. I just haven't tried that out. It may automatically update, or it may just say, you know, you've hard set it at 1.8 million, and you would have to reset it to the new refresh data set.
Just leave the end number blank?
We'll see what happens. What happens if we leave the end number blank? This is a total experimental session now. So the end number is blank. Hey, that worked. But now, so it's going to reset that end number to 879,000. So it's going to set the threshold up to the maximum. But now I have a mental note of go back to Maps team and the visualization teams and say, hey, is there any way that we could set it so that it's not hard-coded value, but maximum value? And they'll be like, yeah, that's hard, but hopefully they'll listen to me. So that's a great question. Where were we? Okay, so we know that this is a population map. So let's turn this into something that is more useful than a population map. So the way that we do that is by normalizing the data set. So normalizing or standardizing a data set is how you would take generally a raw count value and turn it into some kind of ratio so that for any one of these polygons that you're looking at values for, you can make a direct comparison between them. So if I have counties that have hugely different populations, I can still make a comparison between them because this is 12% and that's 14%, and that's a valid comparison. Or if I'm looking at something by, I'm looking at the population density, number of people per square mile. I can make that direct comparison regardless of how large any of these counties are. So what I want to do is create a calculated field that allows me to have that valid comparison ratio value. So my calculated field here, we'll just put an underscore on that, call it percent poverty, and let me see if I can bump up the size when I do this. So I'm going to do the population below poverty level, make it giant, and we're going to divide that by the population for whom poverty status is determined. So this is just telling me how many people did they count below the poverty line, how many people are in the county total, and I'm going to go ahead and multiply that by 100 just because it saves me from doing the formatting in Tableau. If you have the percents as a decimal, it's really easy to change the format and say, use a percent Tableau. I prefer to just multiply by 100 because then it saves me like 2 seconds or something. Over the course of a lifetime, it adds up. I mean, after 3 years at Tableau, I'm probably at like 10 minutes saved. So now we've got our percent poverty, so let's go ahead and map that and see what kind of patterns we have. So we'll drop our counties on. I'm going to go ahead and just go back to the lower 48. And we'll drop our percent poverty onto color. So now we've got a measure that's actually showing us a little bit more interesting spatial pattern. We don't just see, hey, it's the high population counties. Again, I'm going to get rid of the outlines, just because I think it allows us to focus a little bit more on the patterns. But this is kind of part 2 of almost a one-color map. The other map was like really clearly, this is just like a one-color map because the data distribution is really skewed. This is more of a one-color map because we have a lot of variation in data values. So we have so many different shades of blue that it's hard to pull out any specific pattern. This is where stepped color is really handy. So if I just edit the colors, go to stepped colors, and I'll do 4 steps to make it simpler, we're going to simplify the visual pattern so that now we have 4 equal interval steps, and we can see a little bit more clearly where we have our low value areas, our moderate value areas, and then we can see a couple areas that start to jump out as being the higher values. So what the stepped color does in this case is it just really simplifies that pattern for us. But sometimes you've got a question that isn't related to equal intervals. When I worked with public health folks, do any of you guys work in public health? I see a couple nods. I was always being asked for quantiles because it didn't really matter what the equal interval breaks were. What they really cared about is tell me where the top 25% is. Tell me where the bottom 25% is. And that's something that you can actually do easily in Tableau, but is not exactly the best exposed feature. So in order to do these quantiles, so break your data down into 10% or 20% or 25%, all you need to do is do a quick table calculation in percentiles. So now I have the data from 0 to 100 percentile. So the legend doesn't mean a whole lot here unless you really think about it as bottom 25%, next 25%, the next 25%, and the top 25%. So you'd probably want to maybe change the text on the legend or create a custom legend to tell people these are quantiles. But what it's going to do is it's going to give us a new way of looking at the data that isn't based on the distribution on the number line, but it's going to be based on how many counties fall into each one of these groups. So to look at those 3 side by side, I went ahead and created some little dot plots to show you how those class breaks shake out. So our top one is our continuous color ramp, which is just the general, that is what you get out of the box. You drop something on color, it's a continuous ramp. So you can see the very slight changes in shade as you go all the way from light to dark. We have our stepped color in 4 steps, so you can see harder breaks at equal intervals along the number line. And then you can see our quartiles where the breaks are not evenly sized. So we've got this really long clump of our highest class versus the darkest color, and our stepped color is really a pretty short distance on the number line. Yeah? Can you parameterize the quantiles? You probably could with a calculated field. It would be some if-else statement. So can you parameterize it? Maybe. I might take that on as a challenge. We don't have dynamic parameters, but never say you can't, because you never know. So that's how you would get quartiles, which I think are really useful. If you want something other than quartiles, you want 5 breaks, you want 20% chunks, just change it to 5 steps. If you really want 10%, you want deciles, just keep changing it up to 10. You want thirds, same deal. Just take it down to 3 classes. And so you can emphasize different patterns that way. The fewer classes you have, the stronger the visual signal is going to be between the different colors that are showing up on your map. But sometimes those aren't enough. Sometimes you got something really special in mind, or you know something about your data that's really important to look at with the distribution. So that's when I start using calculated fields to create these custom class breaks. So the first one that I created, I decided I wanted to look at this in 10 units. So 0 to 10%, 10 to 20%, 20 to 30% of the percent poverty. So I created a calculated field for that, for 10-unit intervals, and I just said, if my percent below poverty level, and ignore the fact that the calculated field name is different than the one that I created. That was the secret one that I made in advance so I could pre-write all of my calculated fields. So if it's less than 10%, give it a name under 10%. If it's less than 20, 10 to 20%, and so on. And then I throw this else statement at the end that says not classified, check into this, because that is always my catch, which says you screwed up your calculated field. Just go make sure that this is not an error in the value or an error in your calculation. It just gives me something to latch onto when I'm doing quality control. So if I drop that onto color, all of a sudden I get something that's really, really horrible looking. What's going on here? Tableau is really smart. You know, if I drop a numeric data set onto color, it gives me this nice continuous color ramp. If I want percentiles, it gives me a nice continuous color ramp. I use a calculated field like this, and it gives me something where you are never going to find the pattern in this. If, you can try for a while, and it's going to be hard to sort it out. It can be like, cool, is orange more than green or less than green? Like, no one knows. The reason it's doing that is because I've given these categorical names. Super easy to fix, and it gives you some nice benefits. So Tableau will bring these in as alphabetical, so I'm going to reorder these real quickly. I'm going to put under 10 and just drop it up at the top. So now I've got under 10, 10 to 20, and so forth, and they're in a nice order. If I go back into color, I can grab all of those, pick a color scheme I like. Maybe we'll do blue-teal. It's very pretty. Assign the palette. It's going to go ahead and give me that sequential color ramp. And now I'm using those new class breaks with a color ramp that's more appropriate for the data set. This is going to give you some extra perks. Do it this way, you now have a legend that's interactive. So if I want to highlight specific groups of values, I can do that. While we're here, just some minor tips whenever you're making maps. Generally, the legend title is really awful, and it's going to be whatever you named your classified field. Highly recommend that you go ahead and edit the titles. So up at the top of the legend, there's a little drop-down arrow, and you can edit the title. And this is underscore 10-unit class breaks, which makes sense to me. But for everyone else, it might be good to say something like percent in poverty. And now I have a legend that's actually going to be useful to the average map reader. You have a question all the way over there? That's a good question. We could, and so the values actually don't have any meaning in this case because you can't take the county average and average that and get a state average. What it would do is when I collapse it to the state level, it would then, I think, take the average value at the state level and use the same calculated field to say, is it falling below 10, below 20, below 30, and then use the same color scheme. I think that's what's happening. We can sort that out afterwards. Yeah, you can't aggregate. It's not a good calculation to do in this case anyway. So other interesting things that you can do, so diverging class breaks. So I went ahead and created another calculated field for those. And what I'm doing in this case is I had a specific story that I wanted to tell about this data set. And I wanted to highlight which counties are above the national average and which counties are below the national average. So I want people to be able to pull out those specific patterns really quickly. So that means I had to figure out what the national average was, and I just had Tableau give me the average across the data set. I figured out that it was 16.7%, and then I manually just figured out what the equal interval class breaks would be on either side of that. So now I have class breaks of 1.4 to 9.1, 9.1 to 16.7. And if somebody just looks at these, they're going to be like, cool, some random numbers. So I went ahead and added a note into my third class break that says 16.7 to 24.6, national average is 16.7. So that's going to give people this visual cue and this analytical cue that says anything above this is above national average. Maybe you want to pay special attention to those. Or anything below that you want to pay special attention to. And then we've got our else statement just saying, not classified. Maybe you want to check into this. So we'll drop that on. Again, we're going to get our like total nonsense class breaks. Fortunately, since all of these started with a number, they did end up in the right order. We can go ahead and edit those colors. And this is a little bit different to get these to work with a nice color ramp because we want something that diverges. I want to have one color going up from the national average and one color below it. So I'm going to take my top group, because there are 4 of them, and I'd rather manually pick 2 colors as opposed to 4. And I'll go ahead and make those a red ramp, assign the palette. And then I'm going to take my lower ones. I'm just going to pick a blue ramp. I'm sorry, it's going to look kind of like a political map, but it's not really. And I'm going to pick 2 shades for those. So I just select one of the colors, pick the color that I want to use from the color palette over on the right. Now, I didn't pick the darkest shade of blue because I don't want to imply that this is as low below the average as this class is high above the average. So that's something you just want to keep your eye out for. Also, if you have special colors that you prefer to use, you can also just use a color picker and grab those colors and throw them in. So now I've got this diverging color scheme map that lets me really quickly pull out where are all of the counties that are below the national average. Those are all blue. Where are all of the counties that are above the national average. Those are all in red. And the degree to which they're above or below is going to be shown with the darkness of the shade. So it gives us a nice way of telling that story and gives readers a way of saying, here are all of the things that are right around average. I know everything blue is below, everything red is above. So it gives us a nice way to tell that story. Or you might want to really emphasize a specific story. So I'm going to drop my last set of custom breaks on here and show you what these are. So I went ahead and figured out the class breaks for a 5-class quantile map. We've got a low medium, a high medium, and the highest. And the story that I want to tell here is, I'm writing a newspaper article, and I really want to emphasize here is the band in the United States that has the absolute highest poverty rates, and we need to think about these regions. So I'm going to take this. I'm going to make sure that these are in the right order. So we got our highest, high, medium, medium, low, low, medium. We're going to edit our colors. And what I'm going to do here is, because I really want to emphasize the story of the highest value counties, I'm going to go ahead and pick kind of this gray neutral color for everything that isn't the highest class. And then for the highest class, I'm going to pick a nice bright red. And what that's going to do is it's going to let me see the overall patterns, but it's going to pop the ones that I think are really super important in my story all the way out to the front. And I got a question like all the way at the end, and you're going to have to yell at me. You could, so can I make the class breaks based on a state average versus a national average? There is probably a way to do it using a parameter and then having a calculated field that would adjust based on the value in the parameter. I would have to think about it and do some experiments to figure out how to get it right. So for the calculated field, the suggestion was using the sums instead of the actual values. Yeah, so you could probably do something like level of detail calculations that said, give me up to a certain range. So I'll show you one of the other nice things that you can do with this. So besides being able to jump through and pull out each of the county groups individually, we could make a nicer tooltip, and I highly recommend that you do not use the default tooltips because generally they are super not informative. So let's make something that is a little bit more useful. So we're going to do a county name, comma state name, and then we'll take this, and we'll say something like, has a poverty rate that is considered, and this will tell us the name of the group that we filled in. So it'll tell us is considered low medium. And with this new tooltip, I can now select from inside the tooltip. I think this was a feature that we rolled out maybe in either 10.3 or 10.4. So I can interact directly from the tooltip. So if you find a county that's of interest, you can select everything else that is like it based on a category in your tooltip, which I think is a pretty cool feature. So if I want all of the low mediums, now I have all of the low mediums, and I can directly make those comparisons. Making calculated fields to do classification is probably my favorite thing to do with choropleth maps. So the last thing I wanted to show you with choropleth maps is just to say that I know that sometimes the Web Mercator projection is not your favorite map projection. I see that question often enough. I want custom map projection support, so I do want to point out that it is totally possible to do all sorts of really bad things with map projections in Tableau. For instance, moving Alaska and Hawaii to locations where they don't really exist. This is one of my hobbies at work, and I'll just show you a little behind the scenes in case you wanted to know some of the magic and the fact that this is really just like super cheating. Oh, that's right. Perhaps the United States doesn't really live there. But once you get rid of the base map, it looks great. So this is just kind of a fun trick that I figured out because someone challenged me to do it. And I've written 4 different blog posts on this going through all sorts of different aspects of what are the basics of map projections and how they work in Tableau, to how can you make a US map with Alaska and Hawaii shifted, to how can you make a polar map should you really want to do like Arctic sea ice animations. So those are all up on the blogs, and I hope you enjoy them because I love making fun map projections. So just kind of a wrap up for choropleth maps. Great when you've got geocoding polygons or spatial files, so you brought in your own shape file. You're just going to have one value per polygon. I do want to put in the caveat that, yes, I know you may want to make a bivariate map, and that is one of the sticky notes on my desk of write the blog post on how to make a bivariate choropleth map in Tableau. So probably sometime in the next month, I'll have some details on that if you're interested. The class breaks for your numeric data make a huge difference because I will give you like a big mapping secret. People don't read your legend. They see dark things and they think there's more stuff. They see light things and they think there's less stuff. And so the class breaks that you choose change the pattern a whole lot. You've got a lot of power with how you define those class breaks, and know that somebody may glance at the legend enough to see, oh, here's above national average and below national average, and then they are done looking at it. So you might get 5 seconds of attention. So just remember, the colors that you choose and the way you draw those breaks are going to totally change the pattern that people see. You also want to make sure you generally check the data distribution, see if there are any outliers that might be skewing the distributions. If you use default tooltips and legends and put them up on Tableau Public and I find them, I will shame you publicly. And if you use fun map projections, you should totally send those to me, and I will help you become world famous with all of my 12 Twitter followers. They're real active 12 followers. So let's jump to another map type so we can do some more fun stuff. Okay. How do I get back to, oh, there we go. We're going to build up some proportional symbol maps, and we're going to totally bling out these proportional symbol maps in a sort of Zen-esque style. I like to think of it as Zen-esque. The Zen masters would probably look at it and be like, psh, whatever, but my standards might be low. So we're going to work with some precipitation data from NOAA. So we've got rainfall totals for probably about 100 weather stations across the United States. The map type, this is great when you've got either latitude and longitude values or things that can be mapped to latitude and longitude values. So I'm going to use a city-state combination and let Tableau drop the latitude and longitude on the map for me. But the point is, all you need is a point location and some kind of quantitative value for that point location, because the quantitative value is what we're going to use to size our symbol. So we'll do some basic symbolization. Drop my cities on there. Cool, we got weather stations. We want proportional symbols. I'm just going to grab my annual precipitation. I'm going to drop it on size. I got a proportional symbol map. Easy peasy. We could just stop now. But wait, there's more. So the first thing you're going to do with a proportional symbol map is ask if these are a good size for the symbols. And I'm going to give you some really trusty, serious cartography advice here. And this is a quote, I mean, slightly paraphrased, from one of my favorite dead cartographers, Arthur Robinson. And with talking about proportional symbols, his guidance is that your map should appear neither too full nor too empty. Take that to heart. This is the kind of guidance we can give you. So, too empty, too full. We're going to play, Three Little Bears. It's going to be like, okay, just right. So you're really just going to do some manual adjustment to make it so that you start to just see some coalescence of the points in the areas where you have the densest clustering of symbols. When you've got a lot of overlap, it's good to make sure you have a good contrasting color outline. So I've got a little bit of a white outline on here. If I had a blue outline or no outline, you can't really see those overlaps very well. It's hard to pull out the actual sizes. So sometimes it's good to play around with different outline choices to see what's going to look good, what's going to help you see the differences between the points. So that's nice. Great. Proportional symbol map. Next step. Done. Easy peasy. We can stop. But wait, there's more. So one of the nice things about having different channels that you can encode by on Tableau is we could also drop this precipitation onto color, and we can dual encode. And what that's going to do is it's going to make it so your higher values stand out a lot more. Not only are they larger on the map, they're a darker color, and you're going to have better contrast against the base map. So if you want to really emphasize the pattern, you get a lot more bang for your buck by doing the dual encoding. You can also not use geometric symbols. So the default is always going to be to use a circle. Circles are actually a great symbol for proportional maps because it's really easy for people to get reasonable approximations of this is the value for this symbol. I can look at the legend, and maybe I'll spend more than 5 seconds looking at this one. But I can look at the legend and be like, okay, that's 20. I can get an idea of just looking at this. Okay, that's a little bit less than 20. Yeah, it turns out it's 14. So people are good at estimating the size of circles within reason. But circles are kind of boring. And it may not be the right symbol for your map. So it's always nice to take a look at what some of the shape options are. So I'm going to go ahead and switch over to a shape mark type. And I get this new option on my marks card. So if I go into shape and more shapes, Tableau has all of these cool shapes that I can choose from. And I like that by default it comes with some nice weather symbols. So if I want a precipitation map that maybe has a nice proportional cloud on it, I can just grab the cloud symbol and drop some proportional clouds on there. So it gives it a little bit of extra design. If it's not quite right, or I want something a little bit fancier, you can add in your own custom shapes. So I went ahead and added a nice custom rain cloud. I'm going to get rid of the color on here because I think it looks better. Yeah, not quite there, so let's change the base map. And I'm going to go from the light base map to the dark base map because I'm using a really light colored symbol. So now with the dark colored base map, I've got some nice clouds that stand out a little bit better. So it's fun to play with the symbols a little bit to see if you can get something that's going to be a little bit more matched with your theme. Yeah. Is there a way to adjust the legend so that it shows the clouds? I think you were planted in the audience. This is amazing. He was not actually planted in the audience. But I will show you how to do this in just a second. But first, I'm going to remind you to not forget your tooltips. Default tooltip, It's just like a list of stuff. We could turn this into something way cooler. We'll just do our city, our state. Tooltips are really nice when they've got little sentences in them that people can just pick out really quickly. So here's my city-state, so I get my location, has I've got our precipitation value, inches of rain per year. And I'm going to make our sum of inches of rain a nice blue color because we're talking about rain. And so now I have a tooltip that I screwed up because I got rid of the special symbol that tells it that it was a field. So I'm just going to reinsert that. And now we have a tooltip that instead of somebody having to go through this whole table of information, they can just say, oh, Abilene, Texas, 24.82 inches of rain. Cool. So now let's make a legend. So the circles are the default in the legend. Even if you change to a custom symbol, you're still going to have a default legend that is saying, this is the size circle that is shown on the map. And that's not really what's showing on your map anymore. So there are a couple ways that you can make custom legends. I am going to float some symbols on the map. So I switch over to floating under Objects and grab an image and just drag that image onto the map. And then what you need to do is find the folder that has the symbols in Tableau. There's just the My Tableau repository, so you can grab all those symbols. This one happens to have the really straightforward name of 2-2. And now I've got a little rain cloud. It's a little bit of a process, but I would manually size this so that it is the size of my largest cloud. Drop it on my legend. And then I would make probably 3 others in intermediate sizes, and then position them along the legend so that you've got this idea of what is the actual cloud size I'm measuring against. So when you finish putting that together, you end up with something a little bit like this. So we've got our 4 cloud symbols. And if you have a hard time placing them or sizing them, you can always select them and go to Layout, and there are some options to change the position X and Y by pixel and change the size, width, and height by pixel. So you don't just have to drag them until they look right. You can use those to change them 1 pixel at a time. Of course, you could also channel your inner Zen and just completely get rid of the color ramp as well. So here I have 4 different symbols, and I colored each one of those in Microsoft Paint. So I went super high tech and used the Paint Bucket tool and made 4 different colored symbols and dropped them in. I mean, this really was high tech. And so now I only need 1 legend because I've got both the color and the size, and I manually typed in the inches. So it makes it a little bit of a cleaner legend. I think that, to me, that's channeling my inner Zen. Or you can do it all on a worksheet. And so the worksheet makes it a little nicer because now I have an interactive legend. So if I select any of these, it'll select on the map. So the way this one works, let me unhide my sheets. I made 2 different worksheets, one for the map and one for the legend. So the legend is just a table, and I'm using a symbol for my clouds, and I'm adjusting the size. And I did have to go in and manually drag the size slider until they looked about right to match the size on the map. But once I had that, I just created a dashboard, dropped both vises together, and I've got a nice-looking map with a legend that matches, and the legend is now interactive. This workbook is also available on Tableau Public, so you can just grab it and see exactly how it was done. So our proportional symbol maps, big things to know. You got latitude and longitude, you've got some kind of quantitative value. Put your quantitative value on size and drag the slider, play the 3 little bears, too small, too big, just right. Think about dual encoding, because that's going to allow you to have extra emphasis on the range of values. And think about going to that little extra bit of effort with your design. You're probably not going to do it just for analysis projects, but when you're talking about communicating to a broader audience, taking that extra time to put in custom symbols or make a legend that's a little bit more interactive and moves away from the default legends goes a long way in making the design of your map really appealing to people. So I want to go through one last data type, or map type. We're going to look at point distribution maps. And I'm not going to build this one up quite as much, but I think you'll still enjoy it. So this is from the Las Vegas Open Data. I figured we would do something local. I know you guys are really excited about learning about building permits in Las Vegas. Yeah. It was a good point data set with like 200 data points. It seemed like it would be fun because it means that we can show all sorts of cool stuff. The idea with point distribution maps, you've got latitude and longitude pairs, and what you want to do is understand the changes in the spatial distribution. So you're not aggregating them to polygons most of the time, but you want to see where are things clustered together? How smoothly do they change from one place to another? So take a look at our data set. So here are our Las Vegas building permits from 2004 to 2017. This is actually just the commercial building permits because it's actually, it's 200,000 and some data points, and it's a little bit intense to look at it on one map, so I thought I'd spare you at first. Okay, we got a spatial pattern. Problem. There is so little context in the default base map that you can't really see a whole lot of interest here. There's nothing that you really have as a visual handhold to make sense of this pattern. So I want to make sure that you all know where the options are for the map layers. So for this data set, it ends up being really handy to turn on the streets and highways. And just having the streets and highways, all of a sudden we could start to see different patterns. So I've got this whole swath of commercial construction, and it turns out it's right along I-95. That makes a lot more sense to me than if I don't have the streets and highways on. I just like, okay, there's a line. There's probably a big road. Cool. So thinking about how much context your map readers need is an important part to making sure that they're going to be able to understand the patterns in the data set. Sometimes the context in our base maps isn't quite enough. So with this particular data set, I thought it would be great if I had some building footprints. So I went into Mapbox and I created a set of tiles. So you can use Mapbox tiles really easily in Tableau. You can get a free account with Mapbox. It gives you something like 50,000 tiles a month. It's some number that I've never even come close to using all of my free tier of map tiles any given month. And you can add in the custom detail that's relevant to your data set. So if I zoom in, I can say, oh, here are the Las Vegas North premium outlets, and here are all of the construction permits from the last handful of years that were pulled around this area. I bet they were all attached to those premium outlets. So you can get that context to understand, well, what are the buildings that are associated with these permits? I've also gone ahead and changed the tooltip just so it's a little bit nicer to read, so we can see who is the company that pulled this, what was the permit number, what date was it pulled, what kind of work were they doing, where were they doing it. And it just makes it a little nicer to try and cruise through this data set and understand what's in it. If you want to use Mapbox tiles, I'm not going to load them in specifically, but I will show you where you get this information. So in Mapbox, once you've created a set of tiles, there is an option to share, develop, and use. If you just click on the share, develop, and use, it will take you to this page, and one of the options is use style in GIS apps, and there's a Tableau button. And it will give you this super crazy long URL and a button that just copies it for you. Copy it to your clipboard, and then in Tableau, it's just map, background map, map services. I'm just doing exactly what's in the pictures here. You're going to add a new map, and it's Mapbox. You give it a name. You always have to give it a unique name. And then for the URL that you just copied, you would paste it right here. And I already went ahead and did that so that we could get our building footprints. Or you might want something a little bit more special. I personally am a fan of the Mapbox Pirate base map. It is my favorite. If the conference were in Treasure Island, this would have been way more awesome. But I think this is good enough. The really cool thing about this, if you're working with not local scale data, as you zoom out, it gets really, really cool. They don't have any sea dragons, but there are some really nice ships and other good detail. So I highly recommend Pirate for almost all of your base mapping needs. But there is really a good set of pre-made base maps that the Mapbox folks have created. So some of the options they have, you add these in just like you do the base map tiles that you make yourself, except all you need is your API key from Mapbox. You paste that in, and then you have options for, there's like 14 different pre-made styles that you can load in directly. The basic, the comic one, which I think my grandmother would have loved, because Comic Sans was way her favorite font. emerald, there's a high contrast one, there's outdoors, which has more like trails and contours and stuff, run, bike, and hike, pirates, which I expect you'll all be using, pencil, which is a little sketchy, they've got a watercolor one, there's some, not like sketchy in a bad way, but like, you know, like sketchy. So it's really easy to bring in Mapbox tiles, and I would really encourage you, if our base map tiles don't have the right context for you, the Mapbox tiles are absolutely the way to go. And if you have questions about doing any of that with Mapbox tiles, let me know. We've got a number of tutorials available, and we've got some folks in the office who have spent a lot of time working with their tiles. But I wanted to show you a couple other things about this data set and to point you to some additional sessions where you could get some more detail. Sometimes you end up with point data distribution maps that are really, really dense, and you can't really see patterns. So this is the whole data set, 200 and some thousand points, and it's not really easy to figure out what's happening because there's so much overlap between the points. So sometimes you end up doing transformations on these data sets. So here's an option to do hex binning in Tableau. So we've just simplified this down, so instead of, and it's a really horrible tooltip, this is why you should always customize your tooltips. Instead of showing the raw points, I'm aggregating it into these hexagonal polygons, and I'm just showing the sum of records in each of those hexagons. So it makes it so that I can see the spatial distribution pattern a lot more clearly than I could just with the raw points. Or my personal favorite from the last handful of months is making heat maps, because someone said, oh, but we don't have heat maps in Tableau. It's like, yeah, but we've got a software development kit. I could totally write a Python script and just make my own heat maps. So you can make heat maps, and they're awesome. So here's just another way of looking at the data distribution and transforming it from the raw points and having Tableau tell you a little bit more about the spatial pattern. I guess I should just give you the heads up. If you actually want to know how to do these things, some hex bins and some heat maps, this is what I'm talking about tomorrow, Masters of Hex. Talk with Alan Eldridge, who's one of our masters of sales consulting and everything else cool with Tableau in Australia. Alan and I are talking about all sorts of ways of dealing with dense data in Tableau, and I'm going to do a whole set on dealing with dense spatial data. So you can hear more about that there if you're interested. So the point distribution maps, you got latitude and longitude pairs. You're looking for visual clusters. You don't need to aggregate the data, but sometimes you do want to do spatial aggregation, so create something like a heat map or hex bins, and those are totally great ways of dealing with these data sets. Color encoding can help you with a small number of categories, and you want to make sure that you're paying attention to the base map context, and have good tooltips and legends that don't suck. So just a few last notes. Here's some related sessions. So there are a couple really good ones on basics of mapping. So if you want more of an entry level of how does mapping work in Tableau, I can strongly recommend the Beginner's Guide to Maps, which is being taught by one of the development managers on the Maps team. So that's Pat McKay, and it's a really great session. There's a hands-on training, which I think may be standby list only, but if you'd like a real hands-on getting to know mapping, that would be good to get yourself on that list. Tomorrow morning is the Masters of Hex talk that I'm doing with Alan Eldridge. And then on Thursday, if you want your mind blown, there's an advanced mapping and spatial analysis session, which should be pretty cool, like all sorts of fun things that you can do with spatial data in Tableau. And with that, I think I've got like 1 minute left for questions. So I'll take like one question, and then we can all like gather up front, and then we'll swarm downstairs for lunch. So I'm going to get the one question, and then we'll chat.
So I'm from Canada, and there's some, I don't know if you ever worked with Canadian data, but it's different. So first of all, a lot of geographical differences, like there are no boundaries, so it's more difficult to work with. And secondly, a lot of Canadian population is within 100 miles of US border, so it's kind of concentrated in a very small area. How do you recommend sort of working around that problem?
Okay, so how do you work with data sets where you've got a distribution where they're all clustered in one particular location? So specifically, the question is about along the Canadian border. What I would do is I would probably just zoom in to those ranges and create like long horizontal maps. I mean, there isn't a whole lot you can do about moving geographies, but you could think about potentially breaking it up into smaller sets, because you probably have clusters as well. Like here's the Toronto cluster, and here's a Vancouver cluster. So you could have separate dashboard or separate worksheets and bring them together in a dashboard, so you can get rid of all the empty space in the middle. So that would be my main suggestion. So if there are other questions, feel free to come on up. I don't think they're going to kick us out of here for a few minutes. Thank you, guys.